folder from where that file is located. Isn't that easy? Come on.
Fantastic.
It's also available right from the file menu as well. But that's just the tip of the iceberg with this fella. What's with all these crazy decimal dimensions on this part that we have here?
Well, that's because we use the millimeters, but our customers use the inches. I'm always going into document properties to change the units, so I usually just leave it.
You time waster! Why don't you just use the unit switcher in the status bar to change it on the fly? But let's get to the real crime here. Sheet metal. That really gets me bent out of shape.
That's right, Hatch. You're wasting a lot of time with workarounds trying to figure out things like this up to vertex flange. When you start changing the angle, the length of the flange keeps changing. Now you can just choose parallel to base flange and get the exact result you're after.
Or how about figuring out the length of the flange at an angle from the outside of the bend? You can now reference the outside tangency to ensure that you have the right length flange. So now when it comes time to close those corners, you can get the right size and shape of your part.
You're bending the truth. I'm innocent.
I don't think so, Cookie. Let's take a look at another example where you're trying to control flange length and position. For example, when you have an angled flange and you want to maintain tangency to the end of the part, just like before, as you start changing the angle, existing options don't give you exactly what you're after. But with tangent flange position, you have accurate control. Combine this with tangent bend length, and you have more control over your flanges and your questionable driving habits.
And no more wasting time on trying to add form features either. It's easy now to place them on the part and locate those form tools. Now with the property manager, you can even dynamically rotate, flip, and even utilize configurations. There's no guesswork involved anymore.
It doesn't matter anyway, I can't unfold this part because of the corner reinforcement.
Well, if you were using 2012, you know that you can now select faces to ignore when unfolding a sheet metal part. This means that you should never have any problem unfolding any of your components. And speaking of flat patterns, we know that you've been using draft site to fake a lot of your flat patterns, especially when it comes to swept flanges.
The swept flanges is how it works.
If you'd use the command search, you would see how easy it is to find any tool. Just start typing the name and a list of possible tools is presented. Once you're creating a sweep flange in sheet metal, it's just like any other sweep profile. Pick the profile and the path and that's it. There's no faking flat patterns anymore and it unfolds easily.
Yes, I think we're forming a strong case here.
Yeah, whatever. Is that all you have on me?
No, not by a long shot. I know how much time you've been wasting diameter dimensions in your sketches. If you were using SOLIDWORKS 2012, you could have just placed one diameter dimension and the dimension tool would automatically lock into double dimension mode, saving you a lot of wasted picks and clicks.
What? No way.
Yeah.
Yeah, well, you should also be using the new equation editor at SOLIDWORKS 2012. Now with a single dialog box and an automatic solve order, which we'll enable in a little bit, it has new things like category view, dimension view, and ordered view. You'll notice that when we turn automatic solve order on, we don't have to worry about the order we created our equations in anymore.
And adding equations is fluid and dynamic now. Let's start simple by making one dimension object equal to another. Notice the colors highlighting makes it easy to tell whether you've got the right or wrong syntax.
That's right, Hatch, but you also now have a drop-down that makes it easy to utilize information in the model, such as file properties, functions, and global variables. Also, automatic rebuild reflects those changes instantly, giving us dynamic feedback.
And like equations, we can add global variables and access a list of recently used values, reducing wasted time and typos. We can immediately use those variables in our equations. Sometimes we want more than that in model dimensions. So we can now add those to our equations and utilize the measure tool from the pull down. This creates a reference dimension on the fly, and that means the equations stay parametric, giving us more control and flexibility over our designs.
You can also drive these global variables with an equation of their own, adding more depth to the design. Finally, as always, we can create complex equations, utilizing multiple values inside of the model to solve complex problems with simple solutions, such as the hole spacing on this part.
Well, to be fair, you created those equations in the wrong order, but SOLIDWORKS 2012 took care of that for you with its powerful automatic solve order.
Well, I hope I can change my ways as easy as cracking these equations in SOLIDWORKS.
Well, rehabilitation doesn't come with an automatic rebuild, Cookie.